So we discussed that the graphical representation of motion is a convenient way of representing two quantities on a graph paper. We always find it easy. We have already discussed that the dt graph has distance and time. On the x-axis it has got time, on the y-axis we show either distance or displacement, and then this line OB shows the speed or the velocity. If we have taken distance here, in that case it is the speed. If we have taken displacement, then this shows the velocity. We also discussed that the dt graphs may be uniform and they may be non-uniform depending on the how the distance covered in a one unit of time taken. Let's talk about the velocity time graph or the speed time graph. It is all the same. See, if there can be four situations. There can be a situation when the speed is constant. There is no change in the speed. Here we have taken a case where the initial velocity 10, 20, 30 is 40, and even the final velocity is also 40. So it is constant right from second number 0 or say 1 till second number 5. It is the same constant velocity. Okay, in this case there is no change, so the acceleration is 0. However, you can also find out see, what does this area indicate to you? The area here, that means it is forming up a rectangle. The area formed by AB and the time axis. See, from if we take this as T1 and this point can be T2, so from T2 minus T1, this on the area between this, or you may say if I take this as A, if you mark it, then B, C, D. This is naturally AD into DC. This AD into DC will give you, this is the speed and this is the time, right? The speed has been constant throughout. It was 40 here and it was 40 here. So it is speed into time. Speed into time gives you the distance covered. So this is the distance covered. Let's take another case. In this case, initially it starts with 0 and it keeps accelerating uniformly. On the y-axis we have taken velocity, on the x-axis we have taken time. If we talk about, if we take this one as t1 and if we take this point as t2, then in that case this area this area can be found out. How do you find out this area? See, you can see a rectangle being formed and a triangle being formed. So the distance covered can be found out by the area of A, B, C, D, E. That is area of ABCD plus area of ADE. Area of ADE. This way you can find out this area, and this area means the distance covered. Okay, let us take up another case. See, we have seen when the speed was constant. We have also seen when the speed was uniformly increasing. So this was the case of uniform acceleration. Here there was no acceleration, and if we talk about this case, we have got negative acceleration here. The velocity is decreasing. Initially at 0 seconds, initially when we saw the vehicle, its velocity was 50 km per hour, but it kept decreasing, and after 8 seconds it came to a halt. The velocity became 0. There can be another case also, and in this case it is non-uniformly accelerating. See, here you have acceleration, then you have the retardation, then again acceleration, then again retardation. So these are the few conditions where you have seen the velocity time graph, and I hope now it is very clear that velocity time graph gives you acceleration or retardation, and the distance and time graph gives you speed, and if you take displacement instead of distance, it gives you velocity. I hope you have understood. I'll be sending you some questions later on, so keep revising, keep doing these sums. We'll meet tomorrow again. Till then, it's goodbye from the science desk.